Okay, so let's do 37. So 37, so we learned a lot of stuff about functions class meeting, right? So I'm sorry, I did not write here the 4 steps. So I did example of the 4-step how to, right? So first we are going to replace y by x, x by y. So this is on page, what page is it? 230? Page 238. Y by x and x by y. And then solve for y. Solve for y. You guys want me to write it in, you okay, right? Solve for y. And step number 3. What is step number 3? Replace x coordinate with y and y coordinate with x. First step, right? For the given function. This we do for the given function. Okay? Next step is solve for, from step 1, you look at step 1, from step 1, solve for what? Solve for y. You look at step 1 and solve for y. After you replace, right? And then what is step 3? So we have solved for y, we have y is equal to something, right? Step 3 is instead replace y, we are going to replace from step 1. So this one is, now you go to step 2, from step 2, we look at step 2, replace y with what? What do you replace y with? So this is, when here y coordinate means f of x, right? F of x is the y coordinate here. Here f of x is the y coordinate. Now here y coordinate is the f inverse. That's what we need to find. That's it. Okay, so actually 3 steps. Okay? So remember, we'll do another example. F of x is equal to 2x plus 3 over 4. Find f inverse of x. This means find the, we did an example similar to this. So what do you do now? This means y is equal to 2x plus 3 over 4. Next step. X is equal to 2y plus 3 over 4. You can't miss this, guys, okay? This is only 3-step, very simple procedure. Now what do you do? At this point,
multiply both sides.
solve for y, Now we have fractions, we should know how to solve for y now. We can just cross multiply this or multiply the whole equation by 4. So we get 4x is equal to 4 times 2y plus 3 over 4. Cancel, cancel. So what do you get? 4x equal to 2y plus 3. Solve for y. 2y is equal to 4x minus 3. Divide both sides by 2. Y is equal to 2x minus 3 half. Now what do you do? Are we done? What do you need to do? Y need to be, we don't give the answer like this, because we're supposed to find f inverse of x. We are given x here, we need to, the problem here is find, this is the problem, find, given this, oh I did write that here, okay? Given this, find f inverse of x. Right guys? Because we need to find f inverse of x. So if you give the answer y, it's not good. Okay? So now what do you need to do? Y need to be replaced by f inverse of x is equal to 2x minus 3 half. This means the inverse of the other function. Okay? Now we are going to check here. 2 ways to check here. I'm not going to do this problem because you know exactly how to graph. You're going to graph. If I ask you to graph both functions on the same coordinate plane, which I will ask? Straight lines, you guys know how to graph exactly within a couple of minutes, not even maybe 1 minute the most, right? So what do? We are going to graph, check by graphing, right? Check by graphing, so I'm not going to do this, you guys know how to do it. When you graph, you know the two lines are mirror image of what?
Y.
Two lines are mirror image of
Y.
y is equal to x line. Through y is equal to x line, they are the mirror image. Through y is equal to x line. When you graph this, you can graph these two lines later on, you can graph this. And then we can also check with what? Check with what? Check algebraically. How will you check algebraically? I'm going to ask this. This is a test question. Test question. Check algebraically. What do you need to do? You're going to use the definition to check. Who can tell me what's the definition to check algebraically? This is. You guys, check algebraically. What do you need to do? Plug in numbers. Plug in numbers.
Composition G.
Plug in numbers. I mean, you have to be like, when you say something, make sure it makes sense to something. Plugging numbers, we don't know what to plug numbers, you see what I mean? You have to be careful of your communication, how you're going to say the whole thing. Okay? I know what you're meaning, but when you're saying, try to be more precise as possible. If you just say something just for the sake, most of the time, it's not right. Okay? So just trying to be careful. Look at your notes. You know what to do. You have the notes.
F composition of Gx.
F composition of G of X. We are going to work with this. Now here our G is what? Our G, we are going to take our G as F inverse X. G is F inverse. Both has to be F and F inverse. Because two functions, one is F, The other one is we know F and G are inverse of each other. When we compute this gives us what? This is supposed to give us X. So we need to see what this gives us. Now here, instead of this F inverse, if you can consider this as G means F inverse. Are you following this, class? Okay, so now we are going to write, when you're checking algebraically, we're going to put F composition now. F inverse. We know F inverse means G. This is good enough. Is this good enough to check algebraically?
No.
No, what else you need to do?
Also do
Huh?
The rules, so you do F of F.
F inverse of composition F inverse, composition F. We need to check for both of these. We need to check for this and this. Remember? That's what the definition says. Definition says check for F composition G and G composition F. If F composition G and G composition X both gives you X, then the two functions are what? Inverse of each other. Are you following, class? So in order for you to check algebraically, you need to know what tools you are supposed to use. So we are not telling you to do this. I'm going to say check algebraically using the definition. You have to know exactly what you are doing, class. Questions? That's why you go back to the definition. I'm just going to say use the definition and check algebraically whether these two are functions or not. Given two functions, no, excuse me, I'm sorry. Given two functions, whether the two functions are inverse of each other or not. Okay? So, let's check on this one real fast. What does this one means? F of
F is inverse.
F inverse X. This is that this means. So we are going to start with F. Okay? What is F here? 2x plus 3 over 4. Instead of x, what are you going to put now?
2x minus 3 over 1.
Instead of x here, we are going to put F inverse of x, correct? Remember, always where x is, put the parentheses, okay, at the beginning. So now, what am I supposed to write here?
2x minus 3 over
2x minus 3, 4, 3 over 2. So now simplify this. I can reduce here, because this is all over, right? 2 times 1, 2 times 2. So I take so I get 2x over 2 minus 2/3 over 2 divided by 2, right? This part, I divide this by 2, I divide this by 2, each term by 2. I need to divide this also by what? 2. Let me do it another way here. So we cancel this. We get this, right? So now we have 2x minus 3/2 plus 3 whole thing divided by 2, okay? 2x divided by 2 minus 3/2 divided by 2. 3/2 divided by 2?
3 over 4.
3 over 4.
Can you
Right.
just do 4x minus 3? Yeah, plus 3. It's more easier.
It's way easier.
Yeah. So don't make it.
Yeah, you can do that too. So this is 2x over 2. So this become x. This is 3/4. This is 3 over, divided by, we get 3/2, right? I wonder why we get 3/2 here. If we do the other way, we get 4x.
4x minus 3 plus 3.
Yeah, 4x minus 3/4. No, that's is still the same.
No. 4x minus 3 plus 3 equals x. We can have x.
You know what, we wrote this not correct. We didn't write it correct. That's why I know the mistake here. We didn't write this correct. It's supposed to get x. What's the original f function?
2x plus 3 over 4.
2x
Plus 3 over 4.
plus 3 over 4. This is the original x function. Instead of x, we are going to put
2x minus 3
2x.
minus 3 over 2.
I'm dividing everything by 2 here. 2y is equal to 4x divided by 2 minus 3/2. That's right. Okay, so I need to write here 2x, I just want to make sure there's no mistake, minus 3/2. So we get 4x
Minus 3
minus
3
3
plus
plus 3
Over 4.
over 4.
No.
Yeah. Right?
And then we get
Because we need to distribute this to distribute inside here,
Yes.
Yes.
right? So these get cancelled
Yes.
and then
and this is x. Yes. Okay?
Yes.
So we just did this part. We got x, so this is good, this is what we need.
Yes.
And then we are not done, we also need to check. Now what?
Inverse.
F inverse
So that.
composition with F. So we start with the,
Original F.
start with F inverse, correct? What is F inverse?
2x
2x, 2x
minus.
minus 3/2. Very good, guys. You know exactly what to do here, okay?
Mhm.
So instead of x, what do you do?
2x plus 3 over 4.
2x plus 3 over 4. See, if you use different color, you know what, when you look at your notes, you know what you did. If you don't use a different color, sometimes when you go back, look at your notes, you might not see exactly what you did. I mean, because, these are new stuff, so it's natural that you forget. The minute you leave this class, you might forget. Okay, so make sure that you have different colors here so that this way, okay? Cancel. So now we are going to rewrite this 2x over 2 plus 3 over 2 minus 3 over 2. These get cancelled. These get cancelled. This is x. So can you do this problem
Yes.
on the test? I'm going to tell you to find the inverse of a straight line function, not a big curve one, okay? Number 2, I'm going to ask you to graph both on the coordinate plane. So you're showing it, this is like plus or minus. Number 3, I'm also going to ask, show it algebraically. Whether they are, check your answer and show the work. So there's points given to this. It's not like you're checking this on your scratch, okay? Also, there will be another question on the test given two different, you don't have to find the inverse, I'll give you the inverse and the function. You need to make sure algebraically whether it's a function or, whether they are inverse of each other or not. So how will you check again? So you have two problems where you're going to use this twice. I'm not going to tell you what to do. I can't. So you need to know how to use the composition. You guys, if you miss this question, there's lots of points. Okay? So now what you do here, in case you get an x here and the other one you get 3x, are they inverse of each other? No. They both has to be x when you simplify. So you need to be careful when you're simplifying. You can't make a mistake. If you make a mistake, then your answer is wrong. So double check on your mistake and make sure you get this right. Okay, class? If you have any questions, you can ask me after class today. Okay, so this is one big question plus the additional question. Inverse, okay. Now know that now it says to use. Now this is another thing that we are going to do, another problem. It's a homework problem that you have. Problem number 37 and 38. I gave you multiples of 3, right?
Yeah.
So 37 and 38 is not multiple. We are not doing this, but this is also similar text question. For inverse. So it says here, given a table, problem number, this is page 245. Given a table, the table is given x and f of x here. So we have -2, -1, 0, 1, 2, 3, and -2, 0, 2, 4, 6, 8. So here you are given a function in terms of what? When you do this function is given in terms of what?
Ordered pairs.
Very good, this function is given in terms of ordered pair. So functions doesn't have to give in terms of graphs only. Functions can be given in terms of ordered pairs. This is the first lesson of our functions, right? Functions can be, so this means x, this is y valid, these are the ordered pairs. Right? So we know ordered pair. Now this problem says find a table for f inverse of x. So you know exactly what f inverse of x means. This is the graph of the function. We can plot these points and create the graph and find f inverse of x means what?
Switch x to y.
What we are doing there? What are we doing here? What are we doing?
Switch to x and y.
We are looking for the inverse. We are looking for the inverse. So how do you look for the inverse? We have x here, we have y here, f inverse of x here, because we are looking for f inverse. We are creating a table for x inverse. So we have to just put the y coordinates for x. This is the y coordinates here. So -2, 0, 2, 4, 6. Very simple. If it's given in terms of table, or if it's given in terms of ordered pairs, you know it's still switch. So what you have here?
same thing.
That's it. Very, 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 very easy. But you have to understand what's this whole story behind. Okay? Okay, so I'm not going. So there's a similar problem. And now, in exercise 39 to 40, does the function have an inverse function? Given the graph, does the function has an inverse function? Now let me tell you this, guys, you have not heard of this before, what I'm going to write. So this is a very important note. Only inverse of some functions, I'm going to write like this, only inverse of some functions are functions. You guys understand what I'm saying here? What does it mean?
So like, you get like a zero.
Can I say inverse of all functions are also functions? No. Only some, not all. I cannot, if you have a true-false question, like say true or false, inverse of functions are functions. Is it true or false? Not all, it has to be all to be true. Inverse of some functions only are functions. Just because we have a graph, that doesn't mean it's a function. You guys see that? So, inverse can be a different graph, right? Inverse is a different graph. But if that graph, if you have a graph like this, and you take the inverse of this, we get like this. Now is this a function? No. See, only some functions are what? Functions. You following that? So this is only some. Or you can say not inverse of all functions are functions. Either way you say, you have to understand exactly what he's saying. Okay? Does it make sense? Okay, so now we're going to say example. Later on, you're going to see that only I'll give you the I'm going to give you the condition. Only what kind of functions are inverse is a function. Only certain kind of functions, when you take the inverse of that function, is always a function. We're going to talk about that a little later, okay? So let's do this now. So problem number 39, only a graph given. So 39, only a graph given. Graph given like this, right? Graph given like this. And the ordered pair here is 4 and 0, and here's 2.5 and 0. This is 4 and 0, 2.5, let's say 3 and 0 here. 0 and 3. Okay? Now we want to know whether the inverse of this is a function. Is the inverse of this a function?
Probably.
So now what do you need to do? We are going to switch, right? Switch the ordered pairs. 4 and 0 becomes 0 and 4. This is 0 and 4. 0 and 4. This become what?
3, 0.
3, 0. So now the new function, sometimes it's very easy to look at the inverse function like you do this, right? Let me draw this correctly, guys, sorry. So I said 3, 1, 2, 3, this is 0, 3, and 1, 2, 3, 4, 4, 0. There is a line going through these. The inverse of this going to be 4, 0. 4, 0 and 3, 0.
In the book, the line intersects at 6, 0, not 4.
No, I mean, I just took a similar example, okay? So now you can see these two graphs are mirror image of what? Okay? And you see any straight line, this is a straight line, any straight line is a, what is this straight line? This, all straight lines are what? Functions, we know that. Y is equal to mx, all straight lines, so this is a function, easy. Okay? Now, let's do the next example. You take this, so we are done with this, right?
Yep.
So all you have to say, yes, this inverse of this is a function. Inverse of this line that is given to us is a function. And show your work. Okay? 40, we are given a graph similar to, let's say this is negative 2n, 0, and this is positive 2n, 0. So this is 0 and 2, and we have a graph going like this. Similar graph you have between here, right?
Okay.
Now this is a function, we know that, right class?
Yes.
Because the vertical line test says this is a function. So this function is not given to you as f of x by u. It's given in terms of graph. Therefore, that's why we said all the, I even had that question on the test. Functions can be given in terms of graphs.
Correct.
See that? Okay, now what do you do? We need to find, we don't know the equation of this. We don't know anything here. We only see the graph. So now what do you need to do? What do you need to do? Anybody? But if we switch the x, yes, we can do that. We can do that. Okay? Now we can also do, what else we can do? If we switch the xy, in this case, it's still, because it's not a curve, it's not a straight line, we don't know what way the curve is going, correct? We are still kind of in the dark little bit, okay? So, is there any other ideas? Any other ideas?
Draw the y is equal to x.
Very good, excellent. So, we are going to draw the y is equal to, this is the sigma, y is equal to x line. Always draw it like this. And we are going to see the mirror image of this through this. Okay? It's a little tricky. So we're going to use that and also use the what?
The mirror image.
The switch the coordinate, both. Okay? Let's see how we can work on this. So the new graph we are going to switch, right? So new graph, if you switch, what is going to, 0, 2 is going to be 2, 0. So this point is here. If this point here, if this point is here, this is the mirror image of this. So you know the mirror image of this from here to here. If let's take a point here, 1 and 1. Let's take a point here, 1 and 1.5, right? And this one is 1.5 and 1 here, right? So we know this side is the mirror image of this side. You guys can see that?
Yes.
Oh, thank you. So this is the mirror image of this. So we got this part. Okay? Now we need to check the mirror image of this here. We know this point is here. Okay? Through this line, what will be the mirror image? This part. We already took this part. Is the mirror image of this part, and if you take this part, what's the mirror image of this part? This part, right? So we have taken care of this whole part from here to here. You guys see that? This is the mirror image of this, they're like coinciding each other. Right? Okay, so now, what's the mirror image of this part? There's a mirror here, right? If the mirror here and you're standing here, the image has to be on this side, you see? Just think of it, you're standing on this side, this is the mirror, the image is this side.
Yes.
So now on the image, we have to check this point. What's the point going to be?
0, -2.
Negative 2, 0 going to be?
0.
0, negative 2. So here you go to 0, negative 2, and you have this point. That's going to be the mirror image of this. This going to be the mirror image of this. Do you see that?
Yes.
So now can you do the curve?
Yes.
How? Connect this. You see now, this is a person from here to here. This is the person's image. Do you guys see that? So not only you're like switching the points, you're also going to look at the what? Look at the mirror image. Are you following me? If you look at the mirror image, it does make sense to, you stand the mirror, the image has to be certain distance away from the mirror.
Yes.
Okay? You have an intuition where the image is going to be, how the image is going to be when the mirror is y is equal to x line. That's why you have to also make sure what is the mirror. Okay? If the mirror is x-axis, then this is not going to look like that, right? If the mirror is x-axis, then the image is like that. You guys know it? Okay, so now we get, when you have a graph like this, so when we have a graph like this, what's the inverse of that? Inverse of this is like this. So this is f of x, this is the f inverse of x. F of x and f inverse of x. We didn't work with formulas here. We don't have the formula to do the algebraical test. But we look at with the graphs. That's another way to consider a function is inverse of each other. We work with the graphs. We have tools to work with to solve the problem without even looking at the algebraical way. Now, now look at this. So I might say to graph the mirror image with respect to y is equal to x, or do the inverse, graph the inverse, and then I'll say is the inverse is a function or not.
Not.
In this case, no, because you know vertical line test will not satisfy this. So this is not a function. Do you guys questions? Please ask. Any questions? So f inverse of x is not a function. Okay. Okay, so that's because I know. Put my glasses somewhere. Ah. See, I told you, my eyesight is so weak now. Just can't see anything. Okay, so 41, 42 similar to this. So 42 you can see is very easy. You're given a graph like this. So I can do 42 here. This is a homework question. The graph is like this, right? So this is 2, 0. We don't know the formula to this. How will you write the inverse?
0, 2.
We go to 0, 2. And we know like this. We know this is the mirror. Starting from here with this, with the mirror, how does it look like?
Curve upward.
You see that? These two are mirror image. Are we good? Now what do you say? Is this a function?
Yes.
Yes, that's a function. Because this satisfies the what test? Vertical line test. Are you good, guys?
Yes.
Okay, so that's that. And then exercise 43 to use the graphing utility. Okay, right now we are not using the graphing utility to determine, okay, we did not cover that part yet, right? Graphing calculator to graph functions. So on the homework, you guys have this yesterday when I gave the, not yesterday, Tuesday. I said 43 to 48 also. Too much, so you don't have to do those, okay? Anything that we have not covered, when I say 1 through 60, any section we have not covered, you don't have to do it.
Is that from the 2.6 or the 2.7? 2.7.
Question for you guys.
2.7, sorry. I did 2.7 and 2.6 both yesterday. Now, in exercise 49 to 62, find F inverse, and we have to do the coordinate, same coordinate plane, and all that, I covered that. I think the rest is good. Okay, so we are going to, we're basically done. Chapter review, I'm going to give a review exercise for you guys. So I'm going to start chapter 3. Okay guys, I have to start chapter 3. Okay, work on the homework. Next class meeting I'll do a couple more examples of this from the homework. Okay. So I need to start with chapter 3 so that I was planning to do a couple more examples, but I don't have time. So I think now you know exactly what to do. After you practice, I can do some examples for you guys on the board on Tuesday, in terms of what we covered today at last class meeting, in terms of finding the inverse and graphing, okay? And making sure that inverse is a function. Okay guys, so let me do chapter 3. have a lot of markers that are not good. I need to throw it away. Okay. I have like 20 minutes, 15 minutes to finish this, most part of it. Okay guys, so let's start. Now we know chapter 3 quadratic functions. Have you heard of this before?
Yes.
Yes. What's the basic quadratic function? Basic one? Library of functions, what's the basic one? The basic one, what we covered in terms of quadratic? F of x is equal to?
Ax plus b.
What's the basic one? We did 6 basic functions.
Ax plus b.
Square root of x.
X squared.
Square root of x is not the quadratic function.
X squared.
X squared, the basic one is this. This I did write this as the quadratic function. This is the quadratic function, the basic one. Because this can be written in terms of x squared, this can be written in terms of, let's say, 2x squared, plus 0x plus 0. You see that? What do you mean? So these terms are what? Zeros, that means. So this is the basic one, we know how to graph this.
Yes.
Okay. Now, the other basic one is, this is the basic one, but the quadratic function by definition is given to us. The definition, I gave this to you guys before. F of x need to be written as ax squared plus bx plus c. This is the definition, where a, b and c are real numbers. A, b and c are real number. So whenever we call this a quadratic function. Now sometimes there's no b term, bx term, sometimes both these terms are not there. Okay? So we did an example. So now we are going to see how to graph quadratic functions. I did this long time ago. Example, f of x is equal x squared plus 5x plus 6. We know your a, you know your b. How to graph something like this? By using, I'm not going to do this guys again, by using, I said 4 things. What are the 4 things? It's in your notes. By using number 1. What is it?
Quadratic formula.
We are going to graph this by using anybody? What's it? Table of ordered pairs. If you use the table of ordered pairs, you don't know how the graph looks like, right? We don't know how to, this is not a straight line. This is a curve, so we don't know exactly how the curve look like. So you don't know where the curves, how to connect the points. So how did we graph this? You guys did this in beginning algebra, intermediate algebra.
X and Y intercept, finding X and Y.
First, one case is, yes, one thing we need to do, find the intercepts. Find the intercept. So this is the x and y, x and y. So we find the x-intercept, find the y-intercept. So you have 2 points. What else we need to do? What else?
Find the vertex.
Very good. Find the vertex. Remember guys? Find the vertex. This you need to do. There's lots of word problems coming up. All you need to do is find the vertex to get the answer to your word problems. So you need to know this method, how to find the vertex. Find the vertex. Vertex is the maximum or the minimum point of the graph. You already know this is going to be what sort of graph? This is going to be parabola going upward or downward. This is how the graph is a smooth curve. It's a if A is greater than, going upward if A is greater than 1, going downwards if A is less than 1. So you know these two scenario already. Okay? Now we find the vertex. How did you find the vertex of the x coordinate and the y coordinate? First you find the x coordinate. What's the vertex of x coordinate?
Negative B over 2A.
X coordinate, you find x coordinate of the vertex is negative b over 2a. So you use this to find the vertex of x coordinate. After you find the x coordinate, you substitute the x coordinate to the original formula to find the y coordinate. I did an example, I think maybe the same example, way beginning. Okay? You guys, this is a full test question. Okay, next thing is, this is review from beginning algebra and intermediate algebra. What's the next thing? Third thing that you're going to do. What's the third thing you're supposed to do? What's the third thing? X-intercept, y-intercept, vertex, we have all those now. We look for
Asymptotes?
huh?
Asymptotes?
Through the vertex we are going to draw a line. What is it called?
Minus symmetry.
Axis of symmetry. Use axis of symmetry. Axis of symmetry will give you that's the mirror image, the mirror line. Is equal to what is x is equal to negative b over 2a. This line is the axis of symmetry. Okay, so we're going to pick the other point. So for an example, we have x-intercept here, y-intercept here, x-intercept here, and the other x-intercept here, and the vertex is here, right? So this is the vertex, let's say positive 2 and negative 3, this is the vertex. So through the vertex, we write the axis of
Symmetry.
this is x equal to 2 line. This is x equal to 2 line. See, whatever the x coordinate of the vertex is the axis of symmetry. And then use the axis of symmetry to pick the other point. Use the axis of symmetry to pick the other point. This is the other point. And now you complete the graph. Okay, we did this, guys. Test question class, you need to know how to do this, okay? If you have questions, you can ask me after class. Okay, now. You should not take more than 5 minutes for this. Okay, so the next thing we need to do we are going to use, and we need also, if we have something like this, method 2 of graphing. Method 2 of graphing. Quadratic functions. If we have something like this, we did this, f of x is equal to x plus 2 whole thing squared. This is 3 minus 1, something like this. Do we know how to graph this, class? Yes. You use, what do you use for this? I did an example of this also. What do you, in order to graph this, what are you going to use?
Transformation.
Very good. Use transformation. Use transformation what? Techniques, right? Rules. Use transformation rules. So here, what do you do here? Take the x squared, f of x is equal to x squared, the basic one. Work with this. Move to the left, right? 2. Move to the left 2. And then, what do you need to do? Multiply the y coordinate by 3 first. So each coordinate multiply the y coordinate by 3, and then what do you need to do? Go down again, go down, y coordinate by 1. This is the vertical shift. You guys did a really good job on transformation skills. 90% of you guys did extremely good work on this. Okay? So everybody know how to do this. So the method 2 of graphing is use the transformation. Now is this one, if I ask you to, given this one and ask you to graph using transformation, the other thing is when you have a graph like this way, you know what is your vertex right away. I'm going to tell you something. Okay? So let's see, for now we are going to consider that we already know how to graph something like this. This is also quadratic function. If you simplify this, we can write this like that. Okay? So keep this in mind. Now, gosh, I hate to rush, but I need to finish this. So now if you guys look into page 263, you can see f of x is also given to you like this. A times x minus h whole thing squared plus k. This is also called a quadratic function. This is the standard form of a quadratic function. This is called the standard form of a quadratic function. That one was, the first one is the quadratic function. Okay? This is the standard form. Now when you have this, make sure there's negative here, okay? Then when you have this, if the standard form quadratic function given like this, then h comma k is the, what do you call this?
The vertex.
Vertex of the quadratic graph. We need to only, sometimes we only need to find the vertex. So we know h comma k is the what? Vertex. Now, okay guys, so that's all you need to know. Now look at this. I'm just going to do an example here. I'm going to do f of x is equal to f of x equal to x squared plus 2x plus 1 given like this, and then first you need to I'm going to ask you to convert this in, given this is an example, convert to standard form. So this, you're given the quadratic function, we need to write this in terms of what? Standard form and find the vertex. I'm not asking you to graph first and find the algebraically find the vertex. First you need to convert to standard form. So we are going to do this here. This is also test question. So how will you do this? F of x. This is how you do this. X squared plus 2x, we keep this separate, plus 1 separate. And then you need to complete the square here. Remember the complete the square part? You guys need to review the completing the square part. This write as a completing square. So here we need to take the b part, divide by 2. So x squared plus 2x. So you take this, divide by 2. So you plus, you always add, take 2, divide by 2. This is always dividing by 2. Whatever this, you divide by 2. This is whatever you have. Here you write here. If it's 5 here, you take 5, divide by 2. So now you add these to inside the parentheses you add this, right? This is an additional number you add. So if you add additional number, now in this side, the left hand side, we additionally add what? This, if you simplify, we have additionally added 1. So if you add 1, you need to also what?
Add 1, subtract.
Subtract 1. You need to also subtract 1. Because you're adding 1 here, you're subtracting 1. So that if you simplify all this, you only get these 2. Okay, so it's the original same thing. And then you have another plus 1 here. So I'm adding, so this 2 is what I did. So this is negative 1. These 2 are what I did just to manipulate the left hand side, right hand side, to look like what we want to look like. And this one is this. Now I'm going to, okay guys, I'm going to, this we know it's 1, so complete the square here is, this is always going to be x, you take whatever inside here, 1. If you put this whole thing, x squared plus 2x plus 1 can be written like this. Okay?
Okay.
Now this minus 1 and plus 1 got cancelled here in this case. Okay? So this side is 0. So now you got f of x is equal to this. By looking at this, what's the vertex now? Just write the vertex. This is the, what is negative h here?
Negative 1.
Negative 1, h is negative 1, h is negative 1. What is k? K is 0, this is plus 0. So the k is 0. So this is the vertex. You see that? Question? Riba?
Yeah, would it be the same if you found the vertex and then kind of like put it into this?
No, you need to, when you say convert to standard form, you have to do this, complete the square. We are asking it to do it different way. So you have to show your work here. Okay? Convert it first. So I'll do one more example real fast here. Let's say what we had. What did we had? F of x is equal to x squared plus 5x plus 6. This is going to be a fraction thing, but we can do this. So we go x squared plus 5x, separate this, plus 6 separate, x squared plus 5x plus, what are we adding? 5 over 2 and we need to square that. Sorry, we need to also square this. You see, 1 squared is 1. Okay? We need to square it and add to both sides. So we take 5 over 2 and square it and add to this, add to this, add to this. Then we also need to what? Subtract. Okay? So we also need to subtract 5 over 2 whole thing squared. We add and we subtract. Plus 6. You see that? So this part we subtract. Because we additionally add, we also subtract. How will you pick 5? We come from here to you put it. Now these 3 terms together, how are you going to write? X, always if it's plus sign here, put plus. If it's minus sign here, put minus. 5 over 2. This is with the whole thing square. If you file this, you get this whole 3 terms. Minus, you add these 2 together. This is 25 over 4 plus 6 going to be 24, correct? 24 over 4. So this is going to be what? F of x is equal to x plus 5 over 2 whole thing squared minus 1/4. Now remember guys, when we graph this, so this is the, so what is the h and k? For this one, what's the h and k?
Minus.
Vertex is what here?
Negative.
Vertex is negative 5/2 and negative 1/4. Remember when I did the same graph. We got this for vertex. I remember 2.5 and 1/4. We got this. So we don't have to do that four lines, four steps. Okay? Now it's going to be a little tricky when the original one is given with a number here. I'm going to do an example of that next class meeting. How to convert. We need to pull out the factor here, factor it out and then do something. We'll do an example of that next class meeting. Okay? So guys, let me give you the homework.